Hello, everyone. Hello, and good afternoon. And in today's lecture, I will be going to explain you about the code happy number. Happy number using Java and focusing on digit manipulation, also loops and cycle detection with HashSets. So first of all, what is happy number? So the definition of a happy number is a number is happy if when you repeatedly replace it with the sum of the squares of its digits to process eventually which reaches 1. For example, this is it. So in this test case the number is 19 and the test case n 19 number with iteration number 1 19 is broken up into two numbers 1 plus 9 and they both are squared and added with each other. After that the number we have gotten is 82. Then this number will also go into the next iteration which will make it as 8 square plus 2 squares, that is 64 plus 4, that is 68, and 68 6 square plus 8 square, and then we have reached into the our ideal number which is 100, because after when we break this number up, 1 square plus 0 square plus 0 square will always be coming out the result as one number. And this is what we need, because the happy number definition is that if when you repeatedly replace it with the sum of its square of digits, the process eventually reaches to the number 1, which is considered as happy number. It's an ideal question which can be asked in which is being asked in the exams and also coding interviews sometimes. So this is what you get, and this is what the case when the number is happy. And what if the number is unhappy? When the number is unhappy, then the unhappy number will always go into the loop endlessly, like 2 2 4 16 37. Then we'll reach to the 4 again. 2 4 16 16 is 1 plus 6 square, that is 37. 37 is 3 plus 7, 3 square plus 7 square, that is 9 plus 49, uh, then 58, and then so on, and then we'll reach to the number 4, and then this cycle will repeat again. Cycle is detected, so the output will be false, and this unhappy number loop will run endlessly. So this is what as an unhappy number is. So let's go to the code walkthrough and I'll explain what is this. So what we are doing is I'll break into three components. First will be the sum of square method, and this is the sum of square method. Then we'll go into the isHappy integer method, and then lastly we'll look at the example which we have given in the main method. So in this, I stated that there will be a integer of sum of squares name with the parameter integer n. So what we are doing is that the method extract digits and compute the sum of their squares. So integer sum is initialized as 0, and this will go on until n is greater than 0. Integer digit is equal to n, and this is our symbol for extracting the last digit. Percentage symbol will give the reminder, and uh, when we have done with the number 10, then it will give us the last digit, like 19, then 1.9, like that. Then the digit into digit 1 into 9 will be added into the sum which we have initialized here, sorry. Then it will be divided by 10 to get the last number. I'll show that how. And then it will return the sum. After that we have gone into the method isHappy. So what isHappy will be going to do, it uses a HashSet to detect cycles. This is a head set which is named as scene numbers, and it will go until that number is not equal to 1 and it already doesn't contains in scene numbers. Then it will add that number again. Scene number will be added. That number will be added into the scene number hash set, and n is equal to sum of squares, and it will return n is equal to 1. So let's go on to it. Digit extraction first of all. So n percentage 10, that's the large digit, and n, when we have slashed with n 10, then removes the last digit. When we have divided it, it removes the. So this is the first part of our digit extraction, to get the last digit, and this removes the last digit. This gets the last digit, this removes the last digit. After that, we will be going into the cycle of hash set, and hash set stores C numbers to avoid infinite loops. As we have seen in the case of unhappy number, we want to avoid this infinitely endless loop. So this will be going into our scene numbers. Scene numbers will be added into that number will be added into the scene number, so that we can avoid infinite loops. If a number repeats, it's unhappy. We will print, and after that there will be a termination condition, and that termination condition is return n is equal to 1. Loop starts when n is equal to 1, which is happy, or a duplicate is found, then it's unhappy. So to explain this part of this code, which is summing of the squares, I'll be going to demonstrate by visualization of this number first, which is 19. 19 will go into this integer sum is initialized first as 0, and sum is initialized as first 0, while n in this case is 19 is greater than 0, then it will go into this loop integer digit. 19 will be going to go into this 10. This will result into the last digit, because 1.9 will give us, it will come as this, and this will give us this 9. So it will basically exclude this number, and we'll get the last digit of this number. After that, when we have gotten this last digit of the number, then this 9 number will be going to add it into digit into the sum variable which we created here. 9 into 9, which will give us 81. After that, n remind, and this will give 19. Okay, let's go from here. 19, 10, which will give us the first digit, which is 1. So this one will go into the loop again, the same loop which we came from the 9 root will go into the next. So this will go again in digit. 1 percentage by 10 will give us, the remainder will be some variable. Now will be going to get our number. that is 1 into 1, that 1 into 1 is 1, and it will be added into that number. That means now n, which is 82, will be going to divide it at 10. Now we have gotten the number, same again, 8 square plus 2 square, 2 square again, 2 square, then 8 square, which will give us 64 plus 64 plus 4 square plus 2 square, 4, that will be 68 number. Again, iteration third, 6 square, that is 36, plus 8 square, that is 64. Lastly, we'll get the number 100, which will give us our, our answer, that is 1. I wanted to explain this part of this code because it might seem incomprehensible for some of you, but I wanted to explain it in a simple matter rather than using words. So let's go on to the live demonstration of this. So what this will be going to do is our number is integer 19. So integer 19 will be in the first iteration will be going to broken up into 2. So it will be going to broken up into 2. Integer sum will be initialized as 0 initially, then this loop will run while n is equal to while n is greater than 0. So integer digit n, last digit of the number, which is 9 will be extracted, last digit will be extracted, then the digit into digit, then 9 into 9, then it will be going to 19 is greater than 0. Okay, then the 19 reminded with 10 will be given as the number 1.9. Then that number will be going to digit and digit will be going to sum that number, which will be going to do 82. After that, then we'll get the last number which will be going to 19, and then return the sum. After that, this iteration will be going to run, that is 1 square plus 9 square. This will run until we have not reached the number 1, or that scene number doesn't contains that number. And if it doesn't contain, then these iteration will follow 1 2 3 4, and after we've reached the 4th iteration, we have found a happy number, and then we'll return 1. So first of all, I want to say that why introduce the fact that why are we using HashSet. In this method, I'm using HashSet to efficiently detect cycles and also give our time complexity as O O1, which is for lookups to get this from HashSet. And edge cases are, there are two edge cases, that if instead of 19 there is let's suppose that we have given the integer number as 1, then it will then uh, n is equal to 1 is a happy number by definition. So that's the first edge case. And apart from that, what if there are negative numbers introduced in this? We don't have anything assuming anything in this code. So this code only assumes positive numbers. And and if you want to optimize this code, then you can go with the approach of Floyd cycle detection, which is slow but it will give you fast pointers and will be a better approach if you are looking for optimization. So yeah, that's it. So first of all, as I given you the um, in the starting of this lecture, I told you that in this code there will be cycle detection, digit manipulation, and hash set usage in this code. And after that, I have explained you the code as to what is happening in this whole code. And if you like this video, please like and subscribe, and please subscribe to my channel and support me. Thank you.